Hello, everybody. Today I'm doing an interview with the people from PWR in space. They participated in the EuroC competition and they received the technical and design award.
We are a team from Poland, established in 2017. The goal of the association was to go on Spaceport America Cup, the competition. And at first we were working together with PWR Aerospace, but after the first year, when we failed to get to Spaceport America Cup because of bad design decisions, we decided to part our ways, and from this time we are working alone on project Polyrocket, which was with PWR Aerospace. The project remained, but we are working alone and we are building rockets, and that's our main project. But we are also have two projects that are smaller, like Polyfloater, in which we are doing small balloons that can fly around the globe. They don't fly like to 30 kilometers something, but to 10, 12, and they stay there and fly around the globe. And the polyplane, where we build a plane that helps us to test various components of the rocket.
So, what's your story and your roles?
I can talk a bit about the history of our roles, because in the beginning there was only the project manager, which was the founder of the association, and the rest there wasn't like sharp roles. That it was like there were groups of people that were working on different components, but there were no leader in every group, to be honest. And later on, after the first year, we separated like zarząd. I don't know the English word, don't remember. The president council, something like this. I don't know how to call it. But we took like 6 people. There were 6 people at the beginning that were every person had some expertise in his field, like the recovery, the propulsion, the marketing, and so on. And later on, that's like the decision group kind of blur, and it's not so sharp. And right now, we don't have like every person in the decision group isn't responsible for like his field, but that's more like blur that people can be in a few fields even. How did we meet each other? Like we were just I don't know, recruited the first year. Like I think most of people at the beginning were just recruited to the project, just wanted to build the rocket. I can't tell about people that recruited later, so maybe some of you can.
So the most people basically heard about the project from the social media or friends, and they wanted to participate in such complicated project. So they sent an application to join our club, and after performing few tasks, most of us were became part of the group, and we started to know better each other and take part in more and more complicated things.
So you have a couple of departments. You have the aerostructure subsystem, which is like aerodynamics, the propulsion, where you build engines, the electronics, where you do electronics, the recovery where you recover the rocket, the attitude control, it's like the control of the rocket, the payload, which is what the rocket takes up, simulation or simulates the rocket, and the PR and marketing.
Okay, so as for our structure subsystem, the main goal of the subsystem is to make the fuselage of the rocket, make the cone, the fins, and the tubes, I think, and the interfaces between every tube, and also to integrate everything together. That's the main goal of the structure subsystem. As for propulsion, it is propulsion, like to make the engine. As for now, we are flying mainly on the hybrid engine, on the competition. When we are testing rocket, we also use the solid rocket motor, but we also developed the liquid rocket engine. As for electronics, maybe Janek, can you tell us something?
Okay, our electronic department is separated for some groups and submodules. We are divided for particular boards. So, for example, we are developing boards for recovery, for our main computer, onboard computer, to gather all data from sensors. Also, we have some department responsible for our ground support systems, like electronic responsible for tanking, fueling our oxidizer tank inside the rocket. And that system also allows us to take all procedures remotely. So we have another system also. It is our ground station, when we control all ground processes that we perform during preparing our rocket to fly. And we can monitor all data from the rocket also during the whole mission.
What are your team's goal?
For the short-term goals, for sure, this is the competition in the United States, Spaceport America Cup and EuroC. These are two main competitions for us. As for the long-term goals, it's a bit harder, but I think that every person has different goals, and we don't have, like for the whole organization, it isn't set, to be honest. That's more like for every person, but one of the main goals of the organization is to educate people in making rockets, like to make people know how to do the rockets. And I think that with that, in the future, we can maybe even get some people to work in the space industry. And I think that is one of the main long-term goals of our association.
Why do you want to be part of the Spaceport America Cup?
Because it is the biggest rocket competition in the world, to be honest. There are 150 teams. There is no bigger competition, and the level of the competition is, I think, the highest there. So that's the most prestigious competition, and we want to be the best. So, you know.
How many are you, and what partners and sponsors do you have?
As for how many people, there are 80 of us, I think, something like this. And as for partners and sponsors, then I think that Krzysiu has to take it. I don't know.
Yeah, so basically we do have some sponsorships from sometimes sometimes they're from companies that are like related directly to the space to the space itself, and other times we pretty much just have local local businesses support us. We do have an offer for them that if they support us in a financial way or in other ways, we can put their logo on a rocket, and you can probably see it in the photos all the time. So that's something that we do, and in exchange for some services and other goods. So
How much do you build your rockets, and how much do you outsource?
We are doing by ourselves everything we can. Like, the main reason is the cost, and we don't have really much money, and we have to do everything that we can ourselves. And also, it is, I think, it is more challenging, and we can take much satisfaction from doing it. And we also outsource everything we can't do, which are mainly the metal parts that are quite big, because small parts we can make, but we don't have devices to make bigger parts. As for if it is easy to find what we need in our area, it depends what do we need, because some things are quite easy to get and some are quite harder, so I can't really give you a definite answer.
Like, for example, I saw that your launch rail is made from 8020. How was that easy to find?
Yeah, it is easy because you can buy it on supermarket or something like this, so it's quite easy. But as for example, companies that make metal parts, it's quite hard because no company wants to make one part. They usually want to make a few parts at least, so it's quite hard to get them. And we have like the friendly companies that make for us.
I can set the parachutes as examples here, because these parts are very, very expensive if we want to buy it on the market. So doing it ourselves is also very hard because it needs to be accurate. So we try to collaborate with aero clubs who can give us some old parachutes, and it reduces the costs a lot.
How do you manage your association?
We have Podio platform, which we usually we don't really use, but it is for the most important things. It is our base of knowledge, to be honest. It works more that way. Earlier, we used it quite a lot, and it was used to organize our work. And as for now, we are mainly using Discord and local files, like not the local, but within the groups. Like, for example, our structure has its own Trello with its own tasks. So we have it much more, much smaller chunks of boards. Every department has its own tasks. And as for the integration of everything, we do it usually on Podio, and for some important documents and things like that, we do that on Podio. Main thing we use is Discord to communicate.
How do you manage your budget?
So, as we've said earlier, we do have some partners, like business partners, that will give us money or give us services, but we also do get money from our university, from Wrocław University of Science and Technology, which dedicates basically some amount of money for science clubs like us. Other than that, the tasks of public relation and marketing is to promote our club and our projects in social media. We also organize our attendance at some events related to space or business in general. Whenever we go to events such as Meteor Festival or Loty Rakiet Eksperymentalnych in Drawsko-Pomorskie, which is also an occasion to launch our rockets, we do get lots of we do get to know lots of people. So there are also great occasion for us. We do have some budget strategies, and we also roughly know how much money we need for projects that we want to make in this year, but we need to work around how much money the university and will give us, and how much we'll get from our sponsors. And this is not really something that we know at the beginning of the year, because it's highly it's highly based on luck, basically.
So there was this one time that we have basically crashed our rocket. It was on the Meteor Festival. So like less than 3 meter, 2 and something meter long rocket just got crashed to I don't know, 30 centimeters long. So, but the fun fact about this was that the solid rocket engine actually survived. So we of course went and static fired it again. We were kind of scared that it can blow up or something, but we did in the most safe way we possibly could. And well, it worked fine. So we launched this rocket again, the same engine again, different rocket. And actually it crashed again, but the engine survived again. So now we are good. We will launch this engine again in this year, but we didn't static fire it yet. So hopefully it works. I think it works. The engine looks fine on the outside. There is no damage to it or anything. So I think that's kind of funny, at least for me.
Yeah, it's also funny, like it was in the Meteor Festival, the rocket came down, kind of like a meteor. If somebody would like to join your association, how would he join?
So basically, we do have 2 recrutations in a year. It's always at the beginning of the semester, academic semester. So basically around November and March. The only limit of joining us is to be a student of Wrocław University of Science and Technology, because it's just formal things from the university that they give us, and it's the only limitation. We usually have 2 tasks, and the first is the same for everyone. They need to make a rocket project in OpenRocket. It has to show us whether they are able to learn new things and whether they are able to push themselves to make a project in a short amount of time. So that's the first part. And later they need to actually choose which department they want to join. And the second task is related to the specific department. So in electronics, they usually have to make a project of a board or something like this, or make a circuit and show that it works, basically. And it really depends. It's always different, I would say. Sometimes they're the same tasks, but usually we want to mix some things up.
So now I'm going to ask some technical questions. So how big so size and weight, and how fast are your rockets, and why did they win the technical design award?
Okay, so I can talk about the numbers because I know them quite well. Like our first rocket we built was quite small. It was 60 centimeters in diameter and 6 centimeters, 60 millimeters, sorry, and about 70 millimeters long. It was solid rocket. It flew 120 meters per second. So back then it was quite fast even for the first rocket, because that's something like close to more than 400 kilometers per hour. And it flew to 70 meters. Our second rocket, it was 1.9 meter in 1.9 meter long and 100 millimeters in diameter, and it weighed around 6 kilograms, and it was 160 meters fast, and it flew to 1.2 kilometers. Our third rocket, it was our first rocket we flew on the competition. It was 3 meters long, 21 kilograms in weight, and again 100 millimeters in diameter. The speed was quite high because it was something like 260 meters per second, and the highest it flew, actually it was 4.2 kilometers on the Spaceport America Cup. It flew higher than we wanted. And the last rocket we built, okay, maybe there are 2 rockets, but there is Air 4 rocket and Air 4S. Air 4 was supposed to be our 4th rocket, and it flew on the EuroC. It won the design award, and it is 3.8 meters long, 150 millimeters in diameter. And the speed of it was also 260 meters per second. From the calculation, during the flight it was a bit lower. It was 230, and it flew to 2.6 kilometers. And there is also a rocket Air 4S, which is the same as Air 4 but has different engine, the solid engine Sebastian mentioned, and it flew to 1.4 kilometers, and it also had something like 160 meters per second. About the special things in our rocket, we always try to innovate, and we want to push our boundaries. For example, we implemented the attitude control system, which is an innovation. Judges on EuroC, they liked it, and also they liked our payload, which was the airforms were there, and we wanted to check how the cosmic radiation and changes in acceleration and pressure acts on the airforms. And also we test our rockets before our flights, and we talk a lot about how to design things. So I think that helps with winning the design award.
So for the aerostructure subsystem, from how long do you use fiberglass and carbon fiber? And how hard and expensive are they to use?
So basically, we use fiberglass and carbon fiber from, I think, almost the beginning. Right now, we're using it because it's, I think, the lightest material and the stiffest and the hardest at the same time. So, are this expensive? I mean, it is kind of expensive to buy carbon fiber, The fiberglass is less expensive, it's much cheaper, but still a lot of money for students. But we didn't think of using anything else. Like, we tested some things, but still, the carbon fiber is the best material because you can make a really thin layer of it, and it will be hard, and it will be really good for rocket because we want to make our rocket as light as possible. But for example, if we make smaller rockets like R1, or right now we're making like a two-stage rocket, it will be made of something cheaper, like cardboard or PCV tube. I think that's how it's called. So we can like go for everything, I think. But over the years, we tested a lot of ideas, and the carbon fiber turned out the best. The fiberglass we use for test rockets because it's cheaper, and if something happens to the rocket, like it did sometimes, then it's just cheaper to lose it. But the rocket is having like a much more weight to it, and it's a lot thicker. And the carbon fiber is like a thin material, and it's not really hard to use because if we use it like we have an aluminum tube that we cover with some like I guess it was like a okay, so like a cover layer, just, and then we like vend it, like we vend the fiber glass or carbon fiber, we laminate it with epoxy resin, and then we let it dry, and we heat it up in our fence, and then it just turns out really good. We just polish it, we just cut it the way we want it. So it's not really hard. It just needs a little practice. So when the new people come to a workspace, we just show them how to do it. And every time they do it, it just gets easier and easier. So at first, it might be a little confusing because there are a lot of materials that we use to help us. There is a lot of like techniques, but overall, this is like really fun and and I really enjoy it. So
why do you put the epoxy resin on the fiberglass or carbon fiber?
Okay, so in order to make it like a stiff material, in order to make it work, we need to laminate it somehow. So laminate is something that you mix with epoxy resin, like when you mix, because carbon fiber comes in sheets. So it's a sheet like a paper. Then we roll it over the aluminum tube. And then we need something to like make it hard and stick to each other. And because if we just put like a plain sheets, it will just come out. The glue isn't that good. And the epoxy resin is, I think, the best material to do it because it's, I think, kind of cheap, and we can get it almost everywhere. And that's how you make the laminate. So that's why we use it.
How do you build your hybrid rocket engine? And do you make your solid rocket engines? And if yes, what fuel and oxidizer do you use?
To make a hybrid engine, we have to start with basic assumptions, like how much weight will the rocket, how heavy the rocket will be, and how much thrust do we need, how much propellant and stuff. And then, based on those assumptions, we can calculate the geometry of the solid grain and the injector and the nozzle and stuff. Then, when we have all these calculations completed, we can actually start to make some 3D models of the rocket. And once we have all the engine completed in the virtually in the CAD software, then we start to make the technical drawings, so we can and buy, of course, materials, so we can send those materials and those drawings to the manufacturer. And once we've got the parts ready, we need to assemble everything, see if everything that we have designed is actually correct, and if the manufacturers did some errors or no. When all of this is completed, the grind is prepared, we have the oxidizer and so on, then we can proceed to a static fire. And the static fire is this moment where we know for sure that our engine works or not. And if it doesn't work, usually it takes a few tweaks to make it work better. And that's what, after the static fire, that's basically the moment when the engine is completed. As for the solid rocket, yes, we do our own solid rocket motors, and we are using basically our rocket candy, the potassium nitrate and sorbate.
So you use sugar and potassium nitrate?
Yes, that's right.
Yes, I also do solid rocket engines like that with sugar and potassium nitrate.
Yeah, that's the cheapest type of solid grain.
Are you currently working on new types of engines like liquid-fueled rocket engines, or are you sticking to solid and hybrid?
We are working on the liquid rocket engine. To be honest, we tested it. We built it and tested it, like the small version, 100 newtons. And right now we are designing the bigger rocket engine for 3000 newtons of thrust. The engine runs on nitrous oxide, like the hybrids, and the fuel is right now ethanol. But after the tests, it may change because we are during the test campaign with our liquid rocket engine.
How do you design the engines?
For every engine, the beginning is the same. You have to take some assumptions and calculate the main components. Like it changes with hybrid that you have to calculate the grain, and in the liquid you don't have to calculate the grain, but you have to calculate the heat flux, because it is one of the most important things. So like the core of designing the engine is the same. The things that you care the most about change a bit.
How much harder is it to build a hybrid rocket than a liquid-fueled rocket?
You can't really compare that because it depends really much on the special type of engine. Like, I mean, if you want to make a big with long duration hybrid rocket engine, it will be much harder than short burn duration liquid rocket engine. So I don't think you can really compare it that way. But generally, it is considered that the solid rocket engines are the easiest, hybrid are a bit harder, and liquid are the hardest. The main thing you have to care about in liquid fuel engine is the heat flux, which in hybrids you don't really care during the short burn. In liquid you always have to take it into account. In hybrid with short burns you don't have to. Later on with long burns you have to take care about it, and it's much harder to mitigate that than in liquids, because you have solid fuel that and you can't regeneratively cool the engine. You have to ablatively or another way. And as for the solids, it is the easiest mainly because you don't have to mix anything. Like in the liquid, there is also a problem with mixing oxidizer and the fuel. In hybrid, there is also no such a problem. You have to inject the oxidizer like the most effectively, but you don't have the problem with mixing it. And in solids, there is no such a problem. So every engine has its own problems, to be honest.
Do you have plans to use cold gas thrusters?
No, we don't have plans to use them, mainly because our rockets fly in the atmosphere, and in the atmosphere the cold gas thrusters are not quite as efficient. The attitude control system, so basically movable fins, are much more suited for the job.
How much harder will it be to build a multi-stage rocket?
Well, the hardest thing about multi-stage with rocket engine is the scale of it. It would have to be much bigger rocket, because for the small rockets, you don't really need to make 2 stages. That's one thing. The second thing is that liquid fueled engines aren't suited for small rockets, so you also have to make a bigger rocket. So the size of those 2 rockets would be completely different, so then they can't really compete with one another.
Actually, with specifically liquid fuel multi-stage rocket, there is also a problem, and also with hybrid, there is also a problem during the staging, because the fuel or the oxidizer in the tanks isn't like the liquid flows to the upside of the tank, and when you begin the work of the engine, you run on the gas instead of the liquid, and that's also problematic with like liquid fuels, because when this happens, the engine may even detonate. So that's also a problem. And usually in orbital rockets, you have some gas which is thrusted, and also the tanks are covered with a layer that lets the liquid stay in the outlet of the tank.
How did you make like this tank, which is in this image here?
We machined it in like it is made from the pipe and 2 like tank caps on every side, and they are screwed by the screws. And the pipe we made from the company called Bomar. They made it for us. Also, the tank caps were made there. And we began with determining how much oxidizer do we need. Later on, when we knew how much do we need and what the diameter of the rocket do we have, we knew how long the tank could be, and we could design the whole tank. We, of course, had to take care about the leaks and the endurance, like maybe not endurance, but it had not to burst under pressure, so we also had to care about it. We calculated it, we made the mass analysis, and we also pressure tested it. And yeah, no, it worked well. And one important thing about specifically this tank is that we used screws because we wanted to get inside of the tank. With the previous tank, we welded it and we couldn't get inside, and it was inconvenient for us. So we wanted to go with screws this time.
Do you use a remote way to fill up your rockets with fuel?
Yes, we do. The remote filling system is actually required for the competitions that we participate. And besides that, it's much safer to load the fuel from the remote location.
This looks like a custom circuit board. So I think you developed it. And why didn't you use an Arduino?
So about the development of PCBs, we use it in a software called EasyEda, and then usually we have it made by JLC PCB, which are kind of like popular producers of printed circuit boards. And as for the use of an Arduino, it really depends what you have in mind, because we don't have the Atmega microprocessors, because in flight they tend to reset themselves under like big acceleration. So we use STM32 and ESP32, but we do use the Arduino framework, which means that we basically program these microcontrollers as we would do with like classic Arduino Uno or something like this. So and the sensors that we have, we usually have the pressure sensor, which we can use to determine our height and apogee. And we also have like a handful of different sensors that give us some data, like gyroscopes or magnetometers that give us some additional data. They're sometimes used in like recovery subsystems, but usually they're just for us to have the knowledge of how the rocket actually flew and what was its performance. So it's really important for us to innovate to have this data.
What the gray arrow is pointing, there seems to be on Arduino Nano. Is that an Arduino Nano, or is it something that looks like an Arduino Nano?
The gray, you mean the black board? The black
and the blue one on top.
Okay, these are STM32 microprocessors. The one on top is blue pill, and the one under is black pill. So yeah, they have the blue pill has, I think, STM32F103 microcontroller, and the black pill has the F4 series. So it's like kind of more advanced.
Could a cell phone be used as the control to control a rocket?
It's a very good question. It seems that it could, but actually it's not that simple. We can use it for GPS, but the thing that you point out here, that you can, for example, send the data through like the transmission lines of the telephone transmission lines, is not really true, because in the places that we launch our rockets, you don't really have the required connection, and there is a high possibility of losing the whole rocket like this. And this is why we always use our own GPS system and our own communication using LoRa. I think that there have been some instances of people using phones like for camera footage or something, and it can be used in this way, but they usually just read the data from the phone after the flight and don't really transmit it. And for the controlling of the flight, it is also tricky, because you don't have the GPIO pins that you could use to connect some devices, such as like the DC motors for valves, for example. So you couldn't really control our hybrid engine. And with our more advanced systems, such as attitude control system, it wouldn't be possible at all with using a smartphone. So yeah, I think this answers the question.
Actually, sorry, Krzysiu, but I have to add something, because on one of our first flights, we actually used the phone to get the GPS acceleration and gyroscope data. It was one of our team members' Przemek phone, and actually it worked. Like the GPS worked, and the rest of the data didn't. They didn't record itself, so we don't know. But we tried it, to be honest.
I think you are probably not right, because I remember we get some data from the sensors, but for example, for gyroscope, there is some problem with mobile phone sensor because they record the data with not full angles because they are designed for phone orientation. And for example, for one axis, you can only ranges from minus 90 to 90 degrees. So basically, some sensors are not usable for measure during the flight.
Okay, maybe, but I can try to find the data from this flight.
I
think
remember
that they are on podium.
that Adam and try to analyze this data,
Yeah.
so we gathered
Yeah.
some data.
Yeah, and I have them with the conversation with Adam. So,
How do you make sure that your parachutes don't get tangled?
Okay, so we are projecting our recovery system very carefully. We take into consideration every step. And at first, I want to point out that the parachutes are ejected in separate moments. The drop chute, which is the smaller one, is injected at the EPG, and after a few seconds, it fills with the air, and the rocket falls down about with the velocity about 25 meters per second. At the altitude about 300 meters, we inject the main chute, and the lines don't get tangled because the first chute is already filled with the air. The lines are tangled, and during the following descent, one parachute is up to the another.
Do you use any aerodynamic surfaces to increase or decrease the drag?
Last year, like basically 2 months ago, we've had a small test rocket called Airbreaker, which had a system like this presented here, similar at least. It had those movable fins that were like perpendicular to the airflow and could be moved out of the frame of the rocket and then hidden again. We are also like designing and working on a model for a larger rocket. The Airbreaker was basically 80 millimeters diameter, and the fins were not really large, so they didn't work basically at all. We couldn't record it through the data that we had, like any big change in speed or even acceleration. So it was kind of sad for us, but we are still trying to maybe simulate in some CFD simulation to see whether a larger fin on a like bigger rocket that flies to let's say 3 kilometer apogee will do better, and then maybe we'll try to make a prototype and get the design into one of our main rockets in the future.
Do you have plans to use thrust vector control in the future?
We don't really have plans for that. Maybe some dreams, but not plans. The thrust vector control is kind of tricky because you have the high thrust of the rocket and there is not much space between the combustion chamber and the free thrust. So it's hard to fit all the systems in that small space.
How do you control the orientation of the rocket with the fins?
Okay, so as for now, we didn't really control the orientation of the rocket, but right now we are developing the PCB with GPS, accelerometer, gyroscope, and magnetometer. And it will be used to control the orientation of the rocket. The fins are moving with the servo mechanisms, and also we have a fail-safe system. When the power gets cut off from the board and from the servos, the fins will get back to the position when there are no aerodynamic forces on them, because of the springs that are mounted in the system. So even if something fails, they will get back to the neutral position and won't make the rocket change its trajectory. It will fly as it would fly without the control. But generally, we are going to use the magnetometer, gyroscope, and GPS, and make the Kalman filter to filter the data from these sensors and control the orientation of the rocket.
Do you use KSP?
Yes.
Do you like it?
I think more of the half of our members played it and like it. We even have on Discord we have emotes with emojis with Kerbal.
So I thought you have a good simulator. Is like if you need beta testers, if somebody would like to see it.
I think right now we are kind of in the middle of finishing the version alpha of the project. I can't really tell when it will be available, since there's not really anyone here that could answer this question. And with software that is as advanced as our simulator, it is really hard to tell, because you do have lots of how do you say, opóźnienia? Yeah, basically.
There is a lot of delays, and
yeah.
we can't assume when it will be finished, because a lot of factors can affect.
So Skyward, the Italian group who made part of the EuroC competition, made a video, with a simulation of what their rocket did. Did you see it, and do you know why they would do it?
So actually, the first time I saw it was when you have sent us this video. Earlier than that, I have known the Skyward team because their rocket was named the same as our. It was called Lynx, and R4 was also called Lynx. So that's the thing that we had in common. And I can say that like the simulation itself is really impressive, and I do think that you kind of, at some level, you need to have this type of simulation, because you can just see more things in advance and be ready. If something goes wrong, you can know basically before it goes wrong. So yeah, that's a really good thing to have this kind of software for you.
So, as you said before, your payload is earthworms. How did their ride go?
So payload was actually almost 4 kilograms, because this is the regulations of the competition. The payload needs to be about 1 CubeSat, so it's a measurement for satellites. And we did 3 of them, so we did like a 3U, that's how it's called, so 3 CubeSats together. So the idea was to check the survivability. Oh my god, sorry, and how it will affect the worms inside of there. So we put them in the soil and in just like a ground or something to test it. It was really like fill up to the top, so it wasn't like moving all around inside of this. And also the worms are the creatures that don't really feel any pressure or something, so it can't do it a lot of harm. But we wanted to see if the heat or the high speed or it's a little too low for radiation, but maybe when they put it on space stations, for example, because worms are really good for the environment and for ecosystems because they make the soil better. So maybe if they will launch them someday in space, then it can make a difference, like the radiation or something. So we just want to test it. And it turns out really good because the judges on EuroC really like this idea. So in order to get them there, we need to find a worm farm in Portugal. So it was really hard because in Portugal they don't speak a lot of English. So we need to tell them we need just a few of their worms. And the guy that was selling it was really confused, like why do we want like 30 worms or something? But he gave it to us for free. So really nice of him. I bet he didn't know they will fly to space, so almost space. And they ride safely. They survived. We have a video of them, like we putting them out. So nothing really happened to them. So this was all safe and sound.
And also, I would like to say that we have a plan, also 2 plans for payloads for our next 2 competitions. And we are still in contact with the professor from our university to make. I would like to say that we creating a research project and for our payload, and we contacting with professor from our university. And one project is to find the impact of acceleration and velocity in our rocket to the animal cells and or embryons we will put to our payload in the small lab on chip. Or if it won't work, if we won't be able to create such a thing, we will try to get some processors or something like Arduino or STM32 and try to make algorithm and try to calculate at the time when we were flying. And after this, we will try to make our data safe to SD card and
for the effectiveness of the algorithms. So basically you check the errors between processors that they can or cannot perform the same actions, the same calculations with the same accuracy.
What competitions do you want? Do you want to take part of competitions other than EuroC and the American Space Cup?
Like the main goal, to be honest, is to make better rockets, not the competition itself. But if some interesting competition shows up, I think we will take part in it. But for us, always the goal is to make the better rocket than the last one. And the competition is like the reward for doing so.
What did you learn with the EuroC competition and the other rockets you made?
So about all of the questions, so we have a contact with other teams, and I think this is like one of the funniest part, except Lauchik rocket, of course. So every time there is a competition, we have some like a Discord server or something that we can connect with other teams. We can share some ideas. We can help each other out. And I think this is really like, this is the spirit of the whole event. Like, because the event usually is from Monday to Friday. So it's 5 days and only or to Sunday or something. So there are only a few days that you can launch a rocket, but before you need to show it to the judges, you need to ask some, like answer some questions or something. So so there is a time when you can talk to other teams and learn something from them. They are also really helpful. Some teams even have a whole sewing machine or like a whole recovery system for rockets. I mean, because like they can help you. They have some scissors, they have glue and everything. So there was really, they were really helping each other out. And I think this is the greatest part of these events. And, you know, we learned a lot, like we ask questions about something like, for example, the team for Switzerland has like a really great rocket with some really great ideas. And I was talking to one guy of them for like 2 hours because I wanted to know all of it. And we even use, we even get an inspiration because we are using some of their like solutions in our rocket. We modify them, of course. We give it our own idea, but the inspiration is from them. So the inspiration is also from other teams, not only like books or YouTube or something. We can meet in person and learn something new.
Can you say a bit about the other teams?
So yeah, like I said, for example, I was having a really nice conversation with the FPL rocket team from Switzerland. So they were really nice, and they have like one of the best rockets like I have ever seen, like student rockets. It was really great, and they put they have a documentation of all of their ideas and inventions. They print it out. It was like hundreds of pages, and they just put it on the table so everybody can read their ideas. And it was really great because it's not about competition, because like our main goal is also to spread the word and to share our knowledge, to make everyone know that they can make their own rocket. So they have also the same state of mind. And I mean, all the teams like Skyward, Aris, they were all really nice, and they were helpful to each other, and they were willing to share their knowledge. And I think this is like the best part of it. And they were really great teammates, I guess.
Did you have useful exchanges with the other teams?
Like one useful, let's say, exchange, we can say that, was that we were sleeping in one guy in Orlando house after Spaceport America Cup. He invited us to go there, and we slept there for 2 nights, and it was really nice. The exchange from us was that we had party with him. I hope he liked it.
What went wrong with this rocket?
Okay, so during this launch, what went wrong? We launched the rocket. It flew up quite good. We got every data, like every frame from the flight. Every data, everything was fine, but the speed with which it was getting down was a bit too high, so it ended up this way. And the thing that went wrong was that the signal from the main computer to actuators, we don't know what happened between the actuators and the main computer, but only 2 of the actuators blew up. The actuators are pushing the cone out from the rocket, and they didn't manage to do it. We have 4 of them, only 2 of them blew up, and the cone wasn't pushed out from the rocket, and the parachutes didn't fall out, so the rocket crashed. Also, the problem could be with the thing that there was a delay. After the detection of the apogee, there was a delay in the signal from the main computer, but we don't know. We aren't sure. Like, we have hypotheses, but we aren't sure. Maybe Anek knows more, but I think that nobody knows for sure.
What do you plan to do in 2022?
So our two main goals in 2022 is to build two big rockets. The first one is R4 V2, which is basically a better version of the previous R4, and it is also supposed to fly on to the 10K feet apogee during Spaceport America Cup this year in June. And our second project is the R5 rocket, which is supposed to fly to the 30K feet and is also going to be powered by a hybrid engine. And we plan to use it on the next EuroC in 2022 in September. So those are the plans as for our main rockets. And for secondary rockets, we want to remake the rocket that you have showed us before, which has crashed during the Meteor festival, the R4S, which is our test rocket. And also we have one project for a multi-stage rocket, which is kind of on a early stage of design, and we still aren't sure when it will be finished and when it will fly. So that's all our plans for the body of rocket. And also maybe from other projects, we still want to continue polyfloater and make the meteorological sondes that we sent. And also we are in a process of upgrading our plane that we have built for tests.
What advice would you give to a person who is starting with building rockets?
I think you can. I think I can tell them that it's not bad that you will fail, because, for example, I built rockets. Like, I am in the team that built rocket, and after like 1 year, I tried to make like a small rocket at home and just watch some YouTube videos and everything. And I was like, okay, I built rockets like daily, so that's not a problem. And it failed, and I couldn't figure out what was wrong. And I was like so humbled that day, because like, even if I make it, and even if I'm team and I have the opportunity to work in that environment every day, it's still is a bit of challenge to make it yourself. So if you fail, it's not a bad thing, and you need to try again and again. And the internet is a really great place for all the kind of information you want to get. You should get on some forums in your country. I think even the countries that don't have like a space program or everything, they will, for sure, you will find people that have the same interest, and you can get on some forums, ask some questions, try to make your own like ideas, try to experiment with what you think, because the best way to learn is to practice and make it yourself, and to fail, because if you fail, you can figure out what was wrong and you can try improve and make something new. So for sure, like, just try and try to looking for some information and make a practice, make an experience.
What do you think is the best place to study rocketry?
For sure, space. If you can study in space, that will be the best place. But if we're talking seriously, like for sure, like physics and math are the core like studies that can get you in the environment. So without that, it will be really hard in the future. Like, I mean, you can learn everything by yourself, even if you don't go to college or something. But I think these like a kind of environments are the best to start. In our team, there are a lot of mechanical engineers and electrician engineers. So this is like the main fields that we come from. But we have like people from every industry, and you can try from everything, but like I think the best core studies are math and physics to start. If you have a college that has aerospace engineering, that is a great place to go. But if you don't, math and physics will just fine. You just need to do your own research.
So, what some people think is the most important question is you had a party. How was the party?
Okay, so as for the beer, pivo, yes, we had ideas about taking 4 cans of beers as a payload, but to do that we need a bit bigger rocket in diameter. We need 170 millimeters. As for now, we are doing 150. So maybe in the future we will make that rocket eventually, and we want to try that. As for the sausages, kielbasy, we didn't do that, but maybe we should.
Do you have any questions for me?
So how did you find about us? Like, is the first question.
Yeah, so I'm half Polish, so I was a bit. So I'm half Polish, half Italian. So I searched a bit about the possible rocketry clubs or associations, and I found in Italy the Skyward, and in Poland there's PWR in space.
Okay, and I have a question. What do you want to do in the future? Like, what are your plans?
Well, currently I am working on a liquid-fueled rocket engine. It's hard. I'm using ethanol as the fuel, and for the oxidizer, for now, I'm using air.
So, did you make any engines earlier? The solid rocket or something?
Yeah, I made solid rocket. I think I started like 2 years ago. I made first with sugar and potassium nitrate, as I've told you now. They weren't working. Then I found that to make the percentages of the rockets working higher, you have to like cook the fuel on a pan and put it inside of the rocket like as a caramel, not as a powder. And I got like a 50% chance of them working.
Pavel is really jealous because he's trying to make a liquid rocket from like 3 years. So he really
Not true. I made a liquid rocket. I'm not trying.
So
You made liquid rocket?
Made.
So
It
it's
works.
very inspiring that you started very early on.
Yeah, the question is, what does it mean for a liquid-fueled rocket engine to work? Because like I don't have many resources, so currently it's like a cardboard tube with some pipes, valves, and balloons. It does a flame.
For me, it works. If it doesn't blow up, it works.
Well, if the design does what it's supposed to do, what you initially started with, like the basic assumptions, then I guess it works, right?
Yeah, it has a bit too much fuel for how much air it takes, and it also doesn't make any thrust.
Oh, that may be a problem for an engine.
Are you looking forward to join some like rocket team in the future? Maybe. Are you interested in something?
Yes, there's a school near where I live, and they build the stuff in their school. And so I have the idea to I contacted some of the students, and they should respond the next couple of days. And the idea is to have like a team here.
And will you work for NASA or SpaceX, or will you make your own company and hire us maybe?
I think I will make my own company.
Okay, thank you for answering my questions.
Well, thank all of you for joining this interview and for sharing the passion for rocketry. All the links for the video are in the description, and maybe join PWR in space if you're in Poland.
Yeah, and don't forget to subscribe.
Yeah. Okay. Bye.
Bye.
Thanks for
Well-
the interview.
Thanks.
Good luck.
Okay.